Alright, welcome to day 3 of finding the solution or solving systems using Gaussian elimination. Okay, so here is our first example. It's not any different than yesterday. We're just going to go through some more examples to make sure y'all are comfortable with it. Okay, so just like yesterday, the first thing you need to do is we need to rewrite this system into a matrix using just the numbers. Okay, so we have 3 rows, 1 row, 2 row, 3 rows, and then 4 columns. So our 3 by 4 matrix is going to look like this. Okay, so we have 1x, we have 3 y's, 1 z, and we have it equals 10. Then we have 1x, negative 2 y's, negative 1 z, and it equals negative 6. 2 x's, 1 y, 2 z's, and it equals 10. Okay, so here's our matrix. Right, so what we're aiming to do is get these bottom 3 terms to all be zeros, right? Okay, and then after we do that, we're able to solve using substitution. So the first rule I gave you to kind of get you started, to give you somewhere to start at, would be to take row 1 and combine it with row 2 to get a new row 2 where the x value in row 2 is 0. Okay, so I can't just add 1 and 1 together and get 0. I need to multiply one of these rows by some number to make these two be opposites, right? So since they're the same number but they have the same sign, same number, same sign means they're not quite opposites, so we need one of them, we need to multiply one of them by a negative 1 so that it changes it to a negative 1. So we can add these together and they would cancel each other out, right? So let's just multiply row 1 by negative 1. It doesn't matter, you could do either one. We'll multiply row 1 by negative 1 and then add it with row 2 so that it gives us a new row 2 where the x value in row 2 would be 0. Okay, so I'm going to do negative 1 times row 1, which means times 1, 3, 1, and 10. Negative 1 times 1 gives me a negative 1. Negative 1 times 3 is a negative 3. Negative 1 times 1 is a negative 1. And negative 1 times 10 is a negative 10. So this is my negative 1 times row 1. And we are adding it together with my row 2 to get our new row 2. So row 2 we have 1, negative 2, negative 1, and negative 6. Add these together, negative 1 and 1 is a 0. Negative 3 and a negative 2 is a negative 5. Negative 1 and negative 1 is a negative 2. And negative 10 plus a negative 6 gives us a negative 16. So this is our new row 2. This is the only row that's changing. Okay, so we're going to rewrite our matrix. But we're going to keep row 1 and row 3 exactly how they were. And then we're going to replace row 2 with our new row 2, where we have a 0 for our x. Okay. And then from there, we're closer. We've never gotten a 0 here. We need these two numbers to be zeros. Okay. So step 2 I gave you guys was that we want to add row 1 with row 3 to get a new row 3. Okay. Well, right now, if I were to add row 1 and row 3 together, 1 plus 2 is 3. It doesn't give me that 0 value here, right? We need to add these together and get a 0 from our x value of row 3. So we're going to have to multiply one of the rows by some number to make these two opposites. Okay, so what I could do is multiply row 1 by a negative 2, because a negative 2 and a positive 2 would cancel out. Okay, so we're going to do negative 2 times row 1 plus row 3 equals our new row 3, where we would have 0 as our x value. So negative 2 times row 1, which is 1, 3, 1, and 10. Negative 2 times 1 gives me negative 2. Negative 2 times 3 is a negative 6. Negative 2 times 1 is negative 2. And negative 2 times 10 is a negative 20. So this is negative 2 times row 1, and we want to add it to row 3. And our row 3 was 2, 1, 2, 10. So we add these together, negative 2 and 2. Oh, and we're going off the screen. Give me 1 second. Oh. There we go. So add these together. Negative 2 and 2 is 0. Negative 6 and 1 is a negative 5. Negative 2 and 2 is 0. And negative 20 plus 10 is a negative 10. So this is my new row 3. Okay, so we're just gonna go over here and do our new matrix. Keeping row 1 and row 2 the same this time. But replacing row 3 now with 0, negative 5, 0, and negative 10. So we're close. We now have these two as zeros. We just need to make this one a 0, okay? So step 3 was that we were gonna add row 2 plus row 3 together to get a new row 3 with 0 for the y, okay? If I were to add these two together, they're the exact same numbers. So negative 5 and negative 5 would give me a negative 10. I need them to be opposites. Same number, but opposite signs, right? So we'll just multiply one of them by negative 1 so that it changes the sign, right? So we'll just do negative 1 times row 2 plus row 3 will give us our new row 3. If we wanted, we could have multiplied row 3 by negative 1 and it would still work. So negative 1 times row 2, which is negative 5. Ooh, I should put 0, sorry guys. Which is 0, negative 5, negative 2, and negative 16. So negative 1 times 0 is just 0. Negative 1 times negative 5 is a positive 5. Negative 1 times negative 2 is 2. And negative 1 times negative 16 is 16. And this is our negative 1 times row 2 that we want to add with row 3. Which is 0, negative 5, 0, negative 10. 0 plus 0 is 0. 5 plus the negative 5 is 0. 2 plus 0 is 2. And 16 plus the negative 10 gives us 6. So this is our new row 3. And our last matrix we are doing. Keeping our first two rows the same. And we're just replacing row 3 with our new row 3. 0, 0, 2, 6. Okay, now that we have this, we can now transform our matrix back into a system and actually solve for x, y, and z. Okay, so if I were to transform a matrix to a system, I can see that I have 1x, I have 3 y's, 1 z equals 10. I have 0 x's, negative 5 y's, negative 2 z's equals negative 16. No x's, no y's, I have 2 z's equals 6. Okay, so from there we're going to start with this bottom equation first because there only is one variable in this equation, z's. So we can easily figure out what z is. Okay, so the first thing we're going to do is solve that bottom equation. 2z equals 6. 2 times z, the opposite of multiplication would be to divide. So we divide both sides by 2. 2 divided by 2 is a 1. So we get 1z equals 3. So this is one of our answers. And then we're going to use that z to plug in for these other z's to get our y and our x. Okay, so we're doing this equation next where we can plug in our z here and we're only missing the one variable y. So I have negative 5y minus 2 times putting 3 for z. equals negative 16. And we solve. So I'm going to start by multiplying out this and just leaving everything else how it is. Negative 5y. A negative 2 times 3 is a negative 6 equals a negative 16. We want to add 6 to both sides. And we get negative 5y equals a negative 10. Divide both sides by a negative 5. And we get that y equals a negative and negative, make it a positive 2. So if z is 3, y is 2. And lastly, we want to find our x. Okay? So we're saying x plus 3 times my y, which is 2, plus my z, which is 3, equals 10. Okay? So I have x, 3 times 2 is 6, plus 3 equals 10. 6 plus 3 is 9, so we have x plus 9 equals 10. Subtract 9 from both sides, and we get x equals 1. So our full answer is 1 for x, 2 for y, and 3 for z. 1, 2, 3. Okay, so just like the other examples, the first thing we need to do is turn this system into a matrix. Okay, so I'm making a 3 by 4 matrix because we have 3 rows and 4 columns. Okay, so 1x, 1y, 1z, and it equals 6. 1x, negative 1y, 1z, and it equals 10. 2 x's, 2 y's, and negative 1z, and it equals 3. Okay, so here is our matrix. Now what we want to do is go ahead and start out by solving using our steps. So step 1 was row 1 plus row 2 to get a new row 2, but we have to do it in such a way that this new row 2 has a 0 for its x value, right? So right now, if I were to just add row 1 and 2 together, 1 plus 1 is 2. That's not going to give me a 0 here, right? We need these x's to be opposites, so one same number, but one to be positive and one to be negative. So we could just multiply negative 1 times row 1, and then add it to row 2 to get a new row 2 with 0 as my x, okay? Because if I multiply a negative by row 1, I would have a negative 1 here, and a negative 1, a positive 1 is going to give us that 0. So negative 1 times row 1, which is 1, 1, 1, 6. Negative 1 times 1 is negative 1. Negative 1 times 1 is negative 1. Negative 1 times 1 is negative 1. And negative 1 times 6 is negative 6. Okay? So this is my row 1 after it's been multiplied by negative 1. And then I want to add it to my row 2, which we're not changing anything to. So I'm just copying it over as 1, negative 1, 1, and 10. Okay? So negative 1 and 1 is 0. Negative 1 and a negative 1 is a negative 2. Negative 1 and 1 is 0. And negative 6 and a positive 10 gives us a positive 4. Okay? So this is our new row 2 that has 0 for our x value. Okay? So I'm going to rewrite my matrix now. I only created a new row 2, okay? So I'm keeping row 1 how it was above, and I'm keeping row 3 how it was. But then I'm replacing my row 2, okay? So 0, negative 2, 0, and 4, right? So we needed all 3 of these bottom numbers to be zeros. So far we've gotten this one to be a 0, so we still need these 2's to become zeros, okay? So step 2 is we are going to add row 1 and row 3 to get a new row 3, and this row 3 should now have a 0 for my x, okay? So right now if I just added them together how they are, 1 plus 2 would give me a 3, not a 0 like I want. Okay, they need to be same numbers, opposite signs. So what I'm going to do is I'm going to choose to multiply row 1 by a -2, because 1 times -2 would give us that -2, so that we would have opposites. They could cancel each other out. Okay, so I'll just go ahead and put it right here. We're going to multiply row 1 by -2. So -2 times 1, 1, 1, 6. -2 times 1 is a -2. Same again, and then -2 times 6 gives us a -12. So this is -2 times my row 1, and we want to add it to our row 3, which is 2, 2, -1, and 3. Okay, so -2 and 2 is 0, -2 and 2 is 0, -2 and a -1 is a -3, and -12 and a +3 gives us a -9. Okay, so step 2 actually took care of step 3 for us also. Notice that we ended up with 2 zeros, a 0 here and a 0 here. Let's look at it. So I didn't change my row 1. I didn't change row 2. And this is my new row 3, right? 0, 0, -3, -9. So notice our bottom 3 in that bottom corner are all zeros now. So this one, step 2 actually took care of step 3 also. Okay, so we're good. From here, now we can go ahead and transform this back into equations, and then we can solve using substitution. Okay, so to put this into equations, I have 1x, I have 1y, I have 1z, and I have it equaling to 6. For the next row, no x's, I have -2 y's. I actually don't have any z's, and it equals 4. And then on the bottom, no x's, no y's, I have 3 z's, and it equals a -9. Okay, so here are my equations. If you notice, both of these equations only have one variable, so you could start with either one. Since we've been starting on the bottom one, we'll just keep doing that as our first step. So we have -3z equals a -9, and I'm going to solve for z. So divide both sides by -3, and we get z equals a +3. Okay, and then we'll do our next equation. So I just have -2y equals 4. Divide both sides by -2. And I get y equals a -2. And then step 3, we're going to plug our y and our z in. So we have x plus, and y is a -2, so I'm actually going to write -2. And then plus 3 equals 6. -2 and a +3 would give me x plus 1 equals 6, -1, -1, and we get x equals 5. So our answer would be x is 5, y is -2, and z is 3. It always goes in the order of x, y, z. And that's it.